morning. Welcome to my channel Vijay Physics Print. So today we'll discuss about projectile motion. It's a two-dimensional motion. Totally we have two types of projectile motion. First one oblique projectile, and second it is horizontal projectile. In this class I will cover about oblique projectile, and the next class it is about horizontal projectile. So what do you mean by the projectile motion? First of all, if body is projected vertically up, for example you can throw a stone or a ball is vertically projected. In this case the angle with respect to ground, that is theta, is equals to 90 degrees. That is known as vertical projected out body. But in the case of projectile, the angle of projection is less than 90 degrees. Such type of motion is known as projectile motion. See, for example, the bowler is bowling a ball. In this case, the ball follows projectile motion. Water fountain you can take, the water follows the projectile motion. It's completely two-dimensional motion. In the two-dimensional motion, for example, consider a body. Okay, a body is projected up with angle of projection is theta, with initial velocity u, right? So this is a projectile motion. Let the velocity of the body is taken as u. U is the initial velocity of the body, u, and theta is the angle of projection. Now u is resolving into two components because this is a two-dimensional motion. What is a component along x-axis? What is a component along the y-axis? So ux is a horizontal component of velocity. Uy is a vertical component of velocity. What is ux? Ux is equals to u cos theta and uy equal to u sin theta. See here in some numericals, theta instead of x-axis mentioned with respect to y-axis. Just see the angle with respect to x-axis or y-axis. If it is with x-axis, ux becomes u cos theta and uy becomes u sin theta. If respect to y-axis, theta is mentioned with respect to y-axis, then in this case ux becomes u sin theta and uy becomes u cos theta if angle with respect to y-axis. Here with respect to ground or with respect to x-axis, so ux is u cos theta and uy is u sin theta. Now what happened is ux it is unaffected by the gravity, acceleration due to gravity. So ux is no change along the motion, ux, no change in ux, but vertical component is affected by the gravity, so that the uy value is decreases at the maximum height. Vertical component is 0, and when it reaches to ground, again uy is going to be increases. Ux no change, uy decreases, becomes 0, and again increases. So corresponding acceleration, what happens? Ux is equal to u cos theta, no change in its value, so acceleration becomes ax is 0, and vertical component of acceleration ay equal to minus g. I am calculating what is the maximum height reached by the projectile, range, the horizontal distance, and time of flight. So applying the second equation of motion along the x-axis. So the second equation of motion, x is equals to uxt plus of ax t square. So x is equals to ux. What is the value of ux? It is u cos theta t plus of ax is 0 into t square. So x is equals to u cos theta into t, or I am writing t equal to x by u cos theta. So as equation number 1. So horizontal distance can be written as ux is a u cos theta into time. The horizontal component of velocity into total time, it gives the range value or horizontal distance value. So this is with respect to x-axis. Now I am writing with respect to y-axis. That is y equal to uyt plus of ayt square. That is y equal to uyt plus of ayt square. That is y equal to uy is nothing but u sin theta into t of ay minus g into t square. Y equal to u sin theta, t is nothing but x by u cos theta, and of course this is minus g by 2 t square, x square by u square cos square theta. U is cancelled out, then y equal to sin by cos, which is nothing but tan theta into x minus g by 2u square cos square theta into x square. Here for simplicity I am taking tan theta as a and g by 2u square is taken as b. Then y is equals to ax minus bx square. It represents the parabola equation. It means that the trajectory or the path of projectile is parabola. You have to remember the value of a and as well as b. A, it is equals to tan theta, and b equal to g by 2u square cos square theta. Some numericals will be given in terms of y is equals to ax minus bx square. For example, in one question is given like this: y is equals to 4x minus 3x square. It is given like this. Based on this equation, you have to calculate what is the maximum height, range, time. So for that, you have to identify what is a value and what is b value. And then after the maximum height, range, time of flight, in terms of a and b, you have to remember the formulas. I will explain about those formulas in the following concept. So this is parabola equation, y is equals to ax minus bx square. Now I am calculating what is maximum height, range, and as well as time of flight. Okay, so is a projectile motion. Projectile motion. The body is projected up like this. The angle of projection is theta, and u is initial velocity, ux resolving into two components. At the maximum height, no change in horizontal component, but the vertical component is equals to 0. Okay, so what is the initial velocity vector? Vector representation, that is u bar, initial velocity vector u bar equal to ux I cap uy j cap, or initial velocity vector u bar equal to u cos theta I cap and u sin theta j cap. This is initial velocity vector for projectile. Now what is the final velocity? Final velocity is nothing but v bar equal to vxi plus vyj. Vx nothing but initial velocity, no change, that is u cos theta. But what is vy? Vy equal to uy minus gt. Uy, it is nothing but u sin theta minus gt. Now substituting here, we will get final velocity vector vx nothing but ux, that is u cos theta I, vy, that is u sin theta minus gt into j cap. This is final velocity. Initial velocity vector representation and final velocity representation. And what is the angle? That is theta is equals to tan inverse of vy by vx. What is vy? Just now I calculated Vy is equals to u sin theta minus gt by u cos theta. Okay, so this is initial velocity, final velocity, and direction of the projectile motion. Now, what is a change in momentum? So, change in momentum. Change in momentum of this projectile. Change in momentum. Momentum is nothing but mass into velocity. Horizontal velocity remains same, no change in velocity. So change in momentum becomes zero in horizontal direction, but in vertical direction, vertical velocity is going to be changed, right? This is ux and this is uy. Final momentum minus initial momentum. Mass of the projectile is m. Final velocity, which is nothing but u sin theta minus of initial velocity, that is u sin theta, but uy, final velocity, initial velocity, both are opposite to each other. Minus of minus becomes plus, that is change in momentum becomes delta p equal to 2 mu sin theta. This is change in momentum in terms of time theta. Sometimes the change in momentum will be given in terms of time of flight t. Then what happens? So time of flight equation, we know that t equal to 2u sin theta by g. I am writing here 2u sin theta. So 2u sin theta becomes t into g. Substitute here. Therefore, the change in momentum becomes m g into t. This is a change in momentum in terms of time of flight, and this is a change in momentum in terms of theta. So remember this concept, the change in momentum. This is okay, change in momentum. Now I'm calculating the expression for the maximum height. So for this, I'm using third equation of motion. Third equation of motion. What is third equation of motion? V square minus u square equals to 2ax. V is the final velocity, initial velocity u, a is the acceleration, and s is the displacement. So with respect to y-axis, that is nothing but vy, uy, and this is ay, sy. Vy is the final velocity, it is 0. Uy is the initial velocity, uy is nothing but already we know, it is u sin theta having square. To ay is minus g, and sy is nothing but height, it is taken as h. That is minus u square sin square theta equal to minus 2gh, minus is cancelled out, then h is equals to u square sin square theta by 2g. So this is the expression for maximum height, or also written as h is equals to uy square by 2g. So this is maximum height equation. Maximum height depends upon the initial velocity. Height depends upon the theta value on the earth. If it is going to planet is going to be changed, then of course g value is also going to be changed. But here the h is directly proportional to square of the initial velocity and also proportional to square of the sin theta. This is about maximum height. So we got maximum height is u square sin square theta by 2g. Now what is time of ascent? The time required to reach the maximum height from the ground, how much of time it will take? That is called as time of ascent. So I am calculating time of ascent using the first equation of motion. I hope you know about the first equation of motion. V equal to u plus at. With respect to y-axis I am writing time of ascent ta. Final velocity is 0, and this is u sin theta minus gta, or gta equal to u sin theta, ta equal to u sin theta by g. This is time of ascent. Or in terms of time, in terms of uy, that is t equal to uy by g. Time of ascent. Here to here, the time of ascent. Maximum height to ground, time of descent. If you ignore the air resistance, time of ascent is same as time of descent. If you ignore the air resistance, time of ascent is same as time of descent. So the total time means maximum height and maximum height to ground. So total time travel, it is called as time of flight. Time of flight. Time of flight means total time remains in the air, nothing but sum of time of ascent and as well as time of descent. That is t equal to, what is time of ascent? U sin theta by g plus td is same as u sin theta by g, which is equals to 2u sin theta by g. This is time of flight equation or total time equation. So this is time of flight, 2u sin theta by g. Any doubts? So this is time of flight and time of ascent, time of descent, time of flight. Now I am calculating range. What is a range? A range is nothing but the horizontal distance covered by the body. So this is the range, the horizontal distance. Already I said to you, range x is equals to ux into t, horizontal velocity into time, horizontal velocity, which is equals to u cos theta, total time, it is 2u sin theta by g, that is x is equals to u square, u into u square, 2 sin theta cos theta, that is sin 2 theta by g. This is range. So range r equal to u square sin 2 theta by g, u square sin 2 theta by g, or also written as, this is uy, this is ux. So 2 ux uy by g. Also formula for range. So I deduce three equations: h, maximum height, time of flight, and range expressions. And of course time of ascent and time of descent also. And we have to must remember the relation between h, t and r is a very important. The relation between time of ascent, time of flight to maximum height and as well as range. Remember these three relations. The first one, h by t square equal to g by 8. Divide these two equations and solve, you will get g by 8. And second, it is equals to h by r equal to tan theta by 4. H by r equal to tan theta by 4. And the third relation, which is equal to r by t square. R is the range and t square is a time period, so time of flight. That is equals to g by 2 tan theta. So remember these three relations. H by t square is g by 8, h by r equal to tan theta by 4, and r by t square equal to g by 2 tan theta. Once a question asked based on these relations, question it is, projectile motion, the body is projected up with some certain velocity u, the body is projecting like this, okay, body travel from A to B, A to B. It will take some time as T1. T1 from A to B, and on its path two more points C to D. It takes T2. T2. T1 from A to B, T2 from C to D. Then what is the height difference between CD and AB? This is the question. See again, on the path of projectile AB, the time taken from A to B, it is T1, and time taken by the projectile to travel from C to D, it is T2, mentioned in the already question. Then what is the height difference between AB as well as CD? So for this, we need these relations. I'm using the first equation, which is h by t square equal to g by 8. So from the ground, okay, this taken as our origin. From the ground, this is h1 and this is taken as h2. Okay, I'm writing the proof or the solution. So h by t square equal to g by 8. Height, it is h1 t square, that is nothing but t1 square equal to g by 8. I'm writing here h1. What is h1? That is g t1 square by 8. Similarly for h2. So that is 8 g2 square by 8. Take the difference h1 minus h2. Take the difference, that is h1 minus h2. h1 minus h2 nothing but h is equals to, what is h1? G t1 square by 8 minus h2 g t2 square by 8. So g by 8 is taken as a common, then h becomes g by 8 t1 square minus t2 square. So this is the height difference between AB as well as CD. This is our first method. So this is calculating height difference between two parts or given points. Then h is equal to g by 8 t1 square minus t2 square. You will get different types of options, just modifying the final answer. So this is the first type of or first method of the problems how they will ask in the examination. So this is the second model of this problem of projectile motion. One problem is mentioned like this. Angle of projection is 45 degree and initial velocity given to body is 10 root 2 meter per second initial velocity, and two poles at the same height, let us take it as 1 meter, same height. So what is the distance between these two poles? Asking the distance between these two poles. So for this, I have to calculate how much of time to travel by this projectile from origin to P, that is T1, origin to R, that is T2. Take the time difference, T2 minus T1, you will get it. That is nothing but time difference, T2 minus T1, and then after we can apply the range, that is nothing but delta x is equals to horizontal velocity into time difference. Okay, I'm calculating time, T1 value. So applying the second equation of motion, uyt plus of ay t square. H is the height, same height 1 meter, that is 1 is equals to uy u sine theta t of g t square, 1 equal to u value is 10 root 2 sine 45 1 by root 2, and this is g value is 10, cancelled out, that is 5t square, root 2 is cancelled, then that is 5t square minus 10t plus 1 equal to 0. This is the quadratic equation in terms of time. So solving for time, I think you know how to solve the quadratic equation. Minus b plus or minus b square minus 4ac by 2a, that is minus b is 10, minus of minus plus 10 plus or minus b square minus 4a 5 into 1 by 2a. A is nothing but again it is 5. So after solving, you will get time value is 1.89 as well as 0.1 seconds. Two time values you will get it. Take the time difference, that is t equal to 1.89 minus 0.1. So that is 1.79 seconds. I need this distance between these two poles. So distance is equals to horizontal velocity into time. That is delta x is equals to u sin theta. U already is given 10 root 2 cos 45 1 by root 2 and time difference is 1.79, cancel out. That is delta x is equal to 17.9 meter. So this is the one type of model on this projectile motion. So this is second model. Already I discussed this first model, now it is second model. Now one more model on the projectile motion. One more method on the projectile based on the equation model it is. The y is equal to ax minus bx square. So what is a value? That is nothing but tan theta x, b value 2g by 2u square cos square theta into x square. So same equation I am writing in terms of range. Then how it is going to be changed? Range, we know that u square sin 2 theta by g. I am writing g by u square value, g by u square, which is equal to sin 2 theta by r. Okay, so g by u square I am substituting as sin 2 theta by r. Therefore the y equal to tan theta into x minus g by u square sin 2 theta by r here 2 and as well as cos square theta into x square. Sin 2 theta, we know that 2 sin theta and cos theta, 2 sin theta and cos theta by 2r cos square theta into x square. Cos is cancelled, sin by cos tan, 2 is cancelled, then y equal to tan theta into x minus tan theta by r into x square. Tan theta x is taken out, tan theta into x, that is 1 minus x by r. It is also one of the form of projectile motion. So remember, sometimes the question it is based on this equation also. This is a basic equation, y is equal to ax minus bx square, and one more equation in terms of the range, that is y equal to tan theta into x into 1 minus x by r. Okay, so one more concept it is, one more model based on a and b values. What is the time of flight, maximum height and range? Just remember the formulas. Sometimes based on this equation also we have to calculate height value, range and time of first center. So if equation is given like this, the first one is angle of projection theta. Theta equal to tan inverse of A. Tan inverse of A, it will use angle of projection. And second, it is the range. Range equation already you know, u square sin 2 theta by g. But in terms of A and B, range is equals to A by B. And third is a maximum height h. H is equals to A square by 4b. H is equals to A square by 4b. It is a formulas in terms of A and B. So remember all these formulas. Sometimes question will be given in terms of A and B. For example, question is given asking like this: y equal to 10x minus 4x square. Then calculate what is the angle of projection, range and height. Then you can use these formulas. Theta equal tan inverse of A, range A by B, and height h is equal to A square by 4b. Okay. Next, one more concept it is complementary angles. Complementary angles. What do you mean by the complementary angles? Complementary angles means the sum of angles which is equals to 90 degree. Those angles are known as complementary angles. In the complementary angles, in the case of complementary angles, theta 1 is the first one angle. This is a range covered by the projectile. And second, theta 2. What is complementary angles? Theta 2. For second angle of projection also, range is same. Theta 1, let us say R1, theta 2, R2. For complementary angles, range values are equal, but the heights are different. Different heights, but same range for the complementary angles. Is one more concept on projectile. Next, one more concept it is. And one problem is mentioned like this. A soccer player or a football player kicks the ball. Kick the ball. So the ball moving in this direction. Okay. Before it touching the ground, one more player is moving towards the ball to catch it. Then how much of distance covered by the second player? This is one more concept to solve the projectile problems. So in those problems, velocity of the ball will be given. So you have to calculate what's the time of flight. Before touching the second player, you have to run towards the ball, so that the time of flight of the ball, which is equals to the time covered by the second player before the ball touching the ground. So the time it is same. So calculate time of flight for the ball, which is equal to time traveled by the second player, and calculate the distance. Distance is equals to velocity into time. Then you will get the value of how much of distance covered by the second player. Okay. So all the concepts are covered in oblique projectile. This is a part 1. And the next video is based on horizontal projectile. And the next video is based on projectile motion on inclined plane. Okay. So if you have any doubts, you can ask the questions in comment box. Like, share and subscribe my channel. Support my channel. Thank you.